In part one of this series on electrostatic gloves, or ESD-safe gloves, I passed 1,000 volts through my body with this megometer, which is actually a DC generate that'll generate 5 volts or 500 volts or 1,000 volts. And my granddaughter asked me, well, why are you still alive if you got shocked with 1,000 volts? The reason for that is pretty simple. It's because voltage is not the same thing as current. And it's not the voltage that kills you, it's the current that'll kill you. And, well, just to refresh here, we'll use the Fluke multimeter to prove that this thing generates 1,000 volts. Oh, I've got to get these wires untangled. So, connect the Fluke up. And right now we're getting ready to generate 1,000 volts. Sure enough, 961 volts DC. That's when we're at the 1,000 volts level. 500 volt level generates 523 thereabouts volts. And at the lowest level, it generates about 5 volts. But the thing is, it generates very little current. So I'm going to take this glove off. And we'll find out exactly how much current is in the circuit that includes me. So I'll connect the wrist strap I'm wearing to the negative side of the generator and connect the positive side of the generator to the positive lead of the Fluke, and we'll connect the common lead of the Fluke to this iron bar. And first, we'll start out at 5 volts here, and we'll find out how much current is passing through here. Oop, I've got to set up multimeter. All right, we're ready to measure milliamps, because there's not going to be any more than that. So, at 5 volts, generating about 60 milliamps. That's not very much. At 500 volts, now I can feel that in my wrist, generating about 200 milliamps. And at 1,000 volts, about 170 milliamps, 160, 150 milliamps. That feels unpleasant, but it's still not enough to kill me because it's actually very little current. I think it takes somewhere between 0.6 and 0.9 amps before it'll cause you any real damage physically. We're not going to go that high. I'd rather live through this experiment. So, let's find out how much current is passing when I'm wearing these latex gloves. Let me get a fresh pair. All right, let's get connected again. And at 5 volts, current is about 2 milliamps or 20 milliamps. But that's what the fluke is saying is passing just naturally, this circuit. That may be 0. Now it's varying, it's going down. As the charge drains out of this circuit, let's go up to 500 volts and see how much current we get here. Only about 10 milliamps when I'm wearing these gloves, and I don't feel anything right now. And at 1,000 volts, whoa, that was unpleasant. I got a real shock in my hand there. Ooh, just turning that a little bit. Now the thing is, I'm sweating more in these gloves. The longer I wear them, the more I sweat. Better contact I get with my homemade wrist strap, and the more contact I get with these gloves. And remember, through the gloves, from the surface of the gloves to my hand, there's actually not a whole lot of resistance there. And we saw the scale change. Let me go back to 500 volts so I can see. Oh, that's unpleasant. The more your hand sweats with this, the more you're going to feel that voltage. And it's not a whole lot of current, but it still feels very unpleasant. If we're getting up in the range of a couple of hundred milliamps, you're going to feel that. Okay, we've got infinite resistance there. Pick this up. Whoa. These are not fun to wear when you're working with high voltages. You're still going to get a shock through these gloves. And there's actually very little resistance between the surface of the glove and your hand. Let's not use those anymore. Latex gloves, bad idea. So, let's take a look at some gloves that are meant to be used with static sensitive devices. The first gloves we're going to look at are these generic cloth gloves. They have some kind of coating on the finger. I believe it was polyurethane or nitrile. I've forgotten. I've got these a long time ago. Let's find out how these gloves work. Now, they're a little bit small. I went to a website and they said, well, what size gloves should I get? Medium, large, or extra large? And they said, well, if your hand is 8.5 to 9 inches around the knuckles, get the medium size. I should have gotten the next size up because small or medium is just a little bit too small for me. These gloves, let's see. Okay. I've got the wrist strap hooked to the negative side of the generator. And we'll take positive side of the generator and connect it to this bar. And we'll measure the resistance of these gloves at 500 volts. I'm feeling a little charge in my wrist. It's not too bad. But these gloves apparently at 500 volts have a resistance of between 20 and 50 kiloohms. 20,000 and 50,000 ohms. That's below any standard that I've read that said you want a resistance between 100,000 ohms and 25 megohms. So these gloves, I don't think I want to trust them. They'll dissipate a charge very quickly as long as you're connected to a common as long as you're connected to ground and whatever components you're working with are connected to ground, or as long as your wrist strap is connected to the component that you're working on. They'll allow you to have a common charge with them, with those components, and for the most part, they'll keep the oil from your skin off of those components, especially with this coating on the fingertips right here. It'll help that. Not only that, but they'll allow your skin to breathe. You can sweat through them. Still, I don't really trust them because they are so thin, and they don't meet the standard as far as I understand it. Now the standards, they're kind of confusing. ANSI has a standard, Europeans have another standard, people in industry have different standards and different ways of measuring these things. I'm not sure how it's going to work. But I've just decided that the standard that I want is gloves that have a resistance of between 1 and 20 megohms. So let's test these CHP uncoated gloves. They're not available on Amazon right now. Don't know why, but I got them a while back because I was anticipating doing this video and I wanted to test different kinds of gloves. Let's find out what the resistance of these gloves is. These have no coating on them. The weave is a little bit tighter than it was with those generic gloves that I had. So, make sure we're connected to the circuit here. Hold the bar at 500 volts. Their resistance is slightly more than what those cheapo gloves were. Is on the 500 volt scale, it's about 500 kiloohms or 50 kiloohms. On the 1000 volt scale, it's about less than that. Maybe 100 kiloohms. No, about 50 kiloohms probably. And I could feel the charge in my wrist here. These perform about the same as those cheap gloves, and they're below my minimum of 1 megohm. So I don't really want to use these gloves either. Incidentally, if you know more about this stuff than I do, please say something in the comments down below, because this is just an experiment for me, and I don't really know anything about it. I know that I'm not adhering strictly to the standard. I know that my test conditions are not ideal. I'm at roughly room temperature, and it's raining outside, so here in the desert, it might be around 50% humidity, and that might be a little high. I don't know. I'm just guessing about what the standard should be from the various opinions I've read on on a whole bunch of websites actually about what the resistance of these gloves should be. But if you know more about this than I do, please tell me, because I want to learn about this stuff. In part 3 of this series, we'll start testing some gloves that are of better quality and that are meant to be used to protect electronic components from static discharge. I hope you come back. Thanks. Bye.